Hello everyone, I am Priyanka Bharti. Today we will learn what the idea is behind pipelining or what is the idea of pipelining. We will also learn pipelining concept in detail and its implementation. Earlier, central processing unit could either fetch or execute at a given time. In other words, the CPU had to fetch an instruction from memory, then execute it, and then fetch the next instruction, execute it, and so on. This is the diagram of non-pipeline. The idea of pipelining in its simplest form is to allow the central processing unit to fetch and execute at the same time. Here an instruction fetches while the previous instruction executes. It allows storing and executing instruction in an orderly process. It organizes the execution of the multiple instructions simultaneously. This is the diagram of pipeline. It is a set of data processing elements which are connected in series. Here, output of one instruction is the input of the next instruction and so on. Let us learn ideas of pipeline in simple words. To understand the idea behind the pipeline, let us take an example of a bicycle. Suppose we have to make a bicycle. For this, we have two people. Assume there are two processes for making a bicycle, that is, assemble the parts and paint a bicycle. First process is assemble. These are the parts of a bicycle. It is being assembled by two people. Second process is paint. After assembling the parts, both people will paint the bicycle. Also assume that each process takes 10 minutes to complete its action. Each bicycle has to go through each process. Suppose there was only two persons working on the making of bicycle, then both persons would have to do the work at both process. They would move along with the bicycle to each new process. In this case, it would take 20 minutes to complete one bicycle. If two such bicycles were to be made, again suppose there is only two persons making bicycle, but now there are two bicycles to be made. Then it would take 40 minutes to complete two bicycles. When the first bicycle was finished, the worker would have to walk back to the start of the process to start work on the second bicycle. If there were 4 bicycles, then it would take 80 minutes to complete them. If someone were looking at the output of the process, they would see a bicycle produced every 20 minutes. This is non-pipelining. Now we have a question in our mind that what should be done to complete the process of making bicycle in less time and more efficiently. The answer is pipelining. Suppose we have to make a bicycle. For this we have two people. Assume there are two processes, assemble and paint. First process is assemble. These are the parts of a bicycle. It is being assembled by one person. Second process is paint. After assembling the parts, the other person will paint the bicycle. If one such bicycle were to be made, let us assume there are two people working on the process of making bicycle. one at each process. As soon as a bicycle is done at one process, it moves to the next process. For example, once a bicycle is done at assemble stage, it moves to the paint stage. It would take 20 minutes to complete a bicycle. If 4 such bicycles were to be made, let us assume there are 2 people working on the process of making bicycle, one at each process. As soon as a bicycle is done at one process, it moves to the next process. For example, once a bicycle is done at assemble stage, it moves to the paint stage. This allows the next bicycle to move into the assemble stage. Because each process can work on a different bicycle, it is possible to be working on 4 bicycles at the same time. It still takes 20 minutes to complete a bicycle. However, if someone is observing the output of the both process, it would appear that the first bicycle takes 20 minutes, but then each succeeding bicycle would only take 10 minutes to complete. It would take only 50 minutes to complete 4 bicycles. This is pipelining. Here, Table 1 and Table 2 shows non-pipeline and pipeline respectively. From Table 1, if someone were looking at the output of the process, they would see a bicycle produced every 20 minutes. However, from Table 2, if someone is observing the output of the both process, it would appear that the first bicycle takes 20 minutes, but then each succeeding bicycle would only take 10 minutes to complete. It would take only 50 minutes to complete 4 bicycles. Now you clearly understand the idea behind the pipeline. Pipeline complete the same task in less time and more efficiently. Let us understand non-pipelining. As we all know, program is a set of instructions. Here we want to execute 3 instructions. Let us say our program has 3 instructions. When all these 3 instructions will be executed, then we can say our program execute successfully. First instruction 1 will be executed, then it will go to execute second instruction. When second instruction successfully executed, then it will go to third instruction. This is called sequential execution. Pipelining is used to enhance the performance. Our computer executes many programs. In our computer, there will be many softwares running. Each software is a collection of programs. Each program is a set of instructions. Now the question is how we can increase the efficiency or speed of computer. The answer is if we execute more number of instructions or programs in less time, then we can achieve high speed. Pipelining is based on this concept. Pipelining is a concept which is used to enhance the performance of the computer by performing multiple execution of the programs at the same time. Non-pipelining is very cheap method. It means we don't need any expensive hardware, but the drawback is speed of execution. The performance of our computer becomes very slow because our computers generally apply sequential execution of instructions. Now the question is how we can overcome this problem, how we can improve the performance of the computer, how we can execute multiple instruction or concurrent execution at the same time? The simple answer is pipeline. How we can implement the pipeline concept? This is the diagram of hardware organization of pipeline. There should be a separate hardware module for fetching and execution. In between them, there should be a buffer. Here, two separate modules are fetch unit and execution unit. In between both modules, there is interstage buffer. Interstage means it is unit present between fetch and execution unit. Here, buffer is a temporary storage place to store some data. Let us discuss hardware organization of pipeline. As soon as fetch unit fetched the instruction, that instruction will be stored in the buffer. Now, fetch unit is free. When the data is available in the buffer, whenever the execution unit is free, it will take data and start execution. When execution unit will start to execute the instruction, simultaneously fetch unit will fetch the next instruction. In this way, we are able to utilize the time of the processor. Multiple instructions can be executed at the same time. In pipelining, more than one instructions are executed concurrently. Pipelining practices the concept of parallelism. This is the diagram of pipelined execution. We want to speed the performance. We want to achieve concurrency. How we can achieve concurrency? What is concurrency? Instruction 1 is being fetched and executed. During the execution of the instruction 1, fetching of instruction 2 will start. Similarly, when the instruction 2 will be executed, during the execution of the instruction 2, fetching of instruction 3 will be started here. Similarly, when the instruction 3 will be executed, during the execution of the instruction 3, fetching of instruction 4 will be started here, and so on. This way, the hardware never sits idle. It is always busy in performing some or other operations. But no two instructions can be executed at the same clock cycle. In this way, we are able to utilize the time of the processor. Multiple instructions can be executed at the same time. Biggest advantage is the performance of the system will improve because of concurrent execution. Biggest disadvantage is to implement more expensive hardware. Pipelining is the process of accumulating instruction from the processor through a pipeline. It allows storing and executing instructions in an orderly process. It is known as pipeline processing. Pipelining is a technique where multiple instructions are overlapped during execution. Here, installing the engine, installing the hood, installing the wheels, all these are done by separate workstations. That means for each task to complete, we need separate manpower, separate workstation. It means few people are doing the work of installing the engine, few are installing the hood, and few people are installing the wheels. In this way, works are divided and takes less time. In 1977, Handler and Ramamurthy classified pipeline processors depending on their functionality. There are two types of pipelines, arithmetic and instruction. First one is arithmetic pipeline. It is used for floating point operation, multiplication of fixed point numbers, etc. For example, the input to the floating point adder pipeline is x is equal to a into 2 summerflex a, y is equal to b into 2 summerflex b. Here, capital A and capital B are mantisas, small a and small b are exponents. Floating point addition and subtraction is done in 4 parts. First, compare the exponents. Second, align the mantisas. Third, add or subtract mantisas. Fourth, produce the results. The intermediate results between the above operations are stored using registers. Examples of arithmetic pipeline processor are star 100, TIASC, Cray1, Cyber Z05. Second one is instruction pipeline. Here the number of instructions are pipelined and the execution of the current instruction is overlapped by the execution of the subsequent instruction. It is also called instruction look ahead. Here, multiple instructions are executed simultaneously. It is more efficient if the instruction cycle is divided into segments of equal duration. Instruction pipeline is used to increase the throughput of the computer system. Depending upon the hardware, different types of processors apply different stages of pipeline. Various stages of pipeline are 2-stage pipeline, 3-stage pipeline, 4-stage pipeline, 5-stage pipeline, and so on. In a pipeline processor, a pipeline has two ends, the input end and the output end. Between these ends, there are multiple stages, segments, such that output of one stage is connected to input of next stage and each stage performs a specific operation. This is two-stage pipelining. In the fetch stage, instruction is being fetched from the memory. It loads an instruction from memory. During the execute stage, the computer performs the operation specified by the instruction. Execute processes the instruction and writes the result back to the register. This is three-stage pipelining. First stage is fetch. In the fetch stage, instruction is being fetched from the memory. It loads an instruction from memory. Second stage is decode. Decode identifies the instruction to be executed. During the decode stage, we decode the instruction and fetch the source operands. Third stage is execute. It processes the instruction and writes the result back to the register. This is four-stage pipelining. First stage is fetch. In the fetch stage, instruction is being fetched from the memory. Second stage is decode. During the decode stage, we decode the instruction and fetch the source operands. During the execute stage, the computer performs the operation specified by the instruction. Fourth stage is write back. If we need to store the result in the destination, it is done during the write back stage. This is five-stage pipelining. First one is fetch. In the fetch stage, instruction is being fetched from the memory. It loads an instruction from memory. Second stage is decode. Decode identifies the instruction to be executed. In the decode stage, we decode the instruction and fetch the source operands. Third stage is execute. During the execute stage, the computer performs the operation specified by the instruction. Execute processes the instruction and writes the result back to the register. Fourth stage is memory access. If there is any data that needs to be accessed, it is done in the memory stage. Fourth stage is write back. If we need to store the result in the destination, it is done during the write back stage. Conflicts. Factors which will cause the pipeline to deviate its normal performance are: first, timing variations. All stages cannot take same amount of time. This problem generally occurs in instruction processing where different instructions have different operand requirements and thus different processing time. Second, data hazards. When some instructions are in partial execution and if they reference same data, then the problem arises. Third, branching. In this, to fetch and execute the next instruction, we must have the knowledge of that instruction. Fourth, interrupts. It will affect the execution of instruction. Fifth, data dependency. It arises when an instruction depends upon the result of the previous instruction. Some of the advantages of pipeline are: as the pipeline length increases, the amount of work done at each stage is reduced. It allows the processor to attain a higher operating frequency, hence increases the performance. By overlapping the stages of execution of different instructions, the speed of execution is increased. Pipelining allows the core to execute an instruction every cycle, which results in increased throughput. Some of the disadvantages of pipeline is: the design of pipeline processor is complex and costly to manufacture. The instruction latency is more. Latency also increases because it takes more cycles to fill the pipeline before the core can execute an instruction. Thank you.